So this is the 2019 higher paper. So like I previously said on the foundation paper, this is the last paper that we actually have access to in terms of before COVID. So we've only got access to this paper and 2 other papers. So the first question is exactly the same as on the foundation paper. Use the information in the table to describe how the burning of the fractions depends upon the size. So the larger the molecule, the more difficult it is to burn, okay? It's more smoky when it burns, okay? Next question then, which is quite unusual for a higher paper, is to draw a bar graph, okay? A bar graph of information. Then you had to draw a trend line to work out where you believed that the carbon 7 would be, okay? So a bit of a different one, quite a difficult scale as well, because there's 50 there, so each of them was 5, okay? And it was minuses, very difficult scale, very difficult question, okay, in terms of bars, because they don't often come up. Then it says one method that would safely put out a bit of spilled petrol. Okay, so think about what you know about petrol. What part of the fire triangle would you use? Remember the fire triangle, you've got heat, fuel, oxygen, okay? It's obviously a petrol fire. You can't put stuff like water on it. So fire blanket, because it's a small petrol fire, removes the oxygen. So the reason is, what is it doing? It's removing the oxygen, okay? Complete combustion. When anything completely combusts, you get CO2 and water, okay? So that would have been 1 mark. Then it was the balancing, bit of easy bit there because carbon was 5, so you had to put 5 there to get carbons, okay? And then the hard bit then was working out, well, you've got 12 there, so you've got working out how many hydrogens and oxygens you needed, okay? Explain why hydrogen fuel cells in cars are better for the environment, okay? So I know there's a lot going on with hydrogen fuel cells and they're hard to store, hard to transport, but better for the environment. When you combust hydrogen or to make them, the only product is water, okay? The only product is water because it's H2 plus O2 makes H2O plus energy, okay? And that energy then can be used to power cars. There's no carbon dioxide being produced, okay? So will not contribute to global warming, okay? There are problems with hydrogen fuel cells. This is so difficult to store, okay? Difficult to store, it's really volatile, but they're looking at environmental things with hydrogen. It's because the only thing that's produced is water, okay? Question then, burning fuel, okay? So apart from measuring the mass of water, describe all measurements that are needed to be taken to calculate, okay? You have to do the mass of the fuel before and after, the temperature of the water before and after. If you don't write before and after, you don't get the mark. Okay, things that need to be kept the same. Distance spirit burner from the bottom of the beaker. You could have done surface area of beaker. Okay. Where you place the thermometer. So there were a couple of them. We have practiced them all in class. This is a big thing that people lose marks on here because they don't write before and after. Then it says, show which one it would have been. It was an exothermic reaction because it's giving out heat, so it's going to be that one there. Then a 3 marks, nice 3 marks, okay. Draw the electron structure below. Draw the dot and cross diagrams to show how bonding takes place during the formation of magnesium oxide, okay. So metal, group 2. Non-metal, group 6, okay. So that's ionic bonding. Ionic bonding, they're going to transfer electrons. All of these things need to be written. You've practiced them loads, okay? Don't let yourself get down. So draw just the outer shell. So you're going to have 2 and 6, okay? Remember, everything needs 8 in its outer shell. So magnesium is going to transfer 2 to oxygen. So oxygen's now got full outer shell. Magnesium's now got full outer shell because it's gone to that shell there, 2, 8. It's lost 2, so it becomes 2 positive. Its new electron structure then is 2, 8. Gained 2, so draw the outer shell, new electron structure 2, 8. It says include the electron structures of the ions formed, okay? So practice it like that, 3 marks. Again, we've spoke about this a lot. This kind of question comes up a lot. Look at the charges. So you've got Na plus, Cl minus, Mg, 2 plus, O2 minus. You don't need to learn them. They're on the table of ions at the back, okay? Mg2 plus is a higher charge than Na plus. The result is in a stronger electrostatic force. Learn that kind of like buzzword. Get it in, okay? Keyword, learn it. Between the ions, so it's hard to break, more energy to break the bonds. So that means there's a higher melting point, okay? Because it's more energy to melt it, to turn it from a solid to a liquid. Tough one here, okay? This is a double bond one. It will only come up on the higher paper, and we spoke about it's just this one and the O2 one you need to learn, okay? Because they share 4 electrons instead of 2, okay? So as soon as you see CO2, you know it's that one to draw, okay? There's no special way to learn it like with the rest of the covalent bonds, okay? You just have to learn that one and the O2 one because they're both double bonds. A bit of a weird way of doing electrolysis then, okay? Looking at the information in terms of which way do they transport, okay, or move, okay? The higher the potential difference, the more reactive they are, okay? And that's metal C, metal B, metal A, metal D, okay? Flow of electricity then between Z and W, okay? It's going to move from the Z to the W, okay? And the potential difference is going to be 0.1, okay? Explain how this shows both oxidation and reduction. Cu2 plus has gained 2 electrons, okay? It's been reduced. Right oil rig down the side. Think about it. Oil rig, okay? It's gained. So it started as 2 plus. It's gained 2 electrons to go to a normal atom. And then zinc has lost 2, okay? So it's oxidation. Then a little bit of a tough question here, okay? You needed to remember this equation from last year, okay? So mass over Mr. Mole. The mass was 523, and then the MR they gave you to work out, so the number of moles was 0.05, okay? Then they were talking about titration. This is what they were doing, so 2 liquids forming that in terms of a titration, okay? What is the purpose of carrying out a trial run? To find an approximate volume, okay? An approximate volume, so you get close to the real value, okay? State whether sulfuric acid or sodium carbonate solution is more concentrated. Sodium carbonate is in less volume, okay? So it's a higher concentration, okay? So the one in the less volume has got a higher concentration. Remember that. Okay, this question then for 4 marks was difficult, okay? Use the information provided in detail of the other 2 stages Joel and Dylan carried out to make pure sodium sulfate crystals, okay? So you had to use the fact that you knew that the sodium carbonate was 25, okay? You got 1 mark for saying that. Another mark then for using these values to work out a mean of the H2SO4, okay? So you got another mark for saying you'd use that amount, okay? Repeat the experiment without an indicator, okay? So there's 3 marks there, and then evaporate water to allow crystals to form, okay? Tough question, but you've seen it now and you know what to do. It's just being savvy and using the information that you've already got, okay, to work it out, okay? Big thing with titrations is repeat them then because you know the value now. Repeat without an indicator so you can then make the crystals because the crystals can't form if you've got the indicator. They'll be funny colours. Write a balanced symbol equation for the reaction when sodium oxide reacts with copper sulfate. If you need to, write it out as a word equation first. So you've got copper sulfate plus sodium oxide. They're going to swap, okay, and you're going to make copper hydroxide and sodium sulfate, okay? Give a test to recognize sodium sulfate. So sodium is a flame test, can be yellow. Sulfate is barium chloride, white precipitate forms, okay? Ionic equation, so the ions that are needed to form magnesium carbonate, so the 2 ions get added together, you make magnesium carbonate, okay? Easier question you think for 2 marks. Go to your table of ions, 1 mark for working out the ions, 2nd mark for doing top swap, drop. Okay, lot of information here to read. Turn to the first question and then read what you need to read, okay? So you're picking out information then within that paragraph of information that are true, okay? So cross out the ones that aren't true as you go, okay? 2 marks. It was a bit funky though because it's 2 marks and you had to have 3 ticks, okay? All right question, okay? Number of sides of pentagons, okay? So we know pentagons have got 5 sides and there were 12 of them. Hexagons have got 6 sides, there were 20 of them, okay? So it was a bit of reading information and picking out how many pentagons and hexagons there were, divided by 2, so 90. This was a really difficult question, okay? Really difficult. A lot of information going on, okay? You were using the fact that it was the radius, the diameter they gave you was 1.1, divided by 2 would give you the radius, okay, which is that, okay. You then had to be able to convert it from meters into nanometers, okay. A lot of people end up with minus 27, okay. So be careful of that. But you would have got 2 marks if you end up with minus 27. Give the main reason why the structure of fullerenes has resulted in there being interest in the development of this use of catalyst. Large surface area for such a small molecule. Why do people oppose them? They haven't been around enough. We don't know the long-term effects, okay? Buckyballs could be good conductors of electricity. Use your knowledge of bonding structure to give one reason the student could support their answer. Similar to graphite, which we know has that free electron, okay? That free electron which can conduct electricity. Okay, because that's the reason you could give to say why you think it could conduct electricity. It's very similar to graphite. Last question then in terms of a 6 marker. So there was one mark for writing what an isomer was. Okay, isomer's got the same molecular formula, different structural formula. Alkanes then, you can use this as quite good revision. That is their general formula. Okay, butane, it said to use butane. That's one example of butane, and then changes in the carbon chain would be another example of an isomer of butane. Okay, you don't need to name them unless you're triple scientists have to name them, but no double award scientists don't. Okay, alkenes then, that's the general formula, because you see there were 3 marks just for definitions running along here. But1-ene then, and you can move the double bond, then but2-ene changes with the double bond, so that's a different way of having isomers. Again, you get additional pages, table of ions. You make sure you're really familiar with this because you're going to have to use it. And a periodic table, so you don't need to worry about all of that is there.